Here we're going to be learning about how to use the quadratic formula, but before we do that, we're going to learn about one part of that that's called the discriminant. So the discriminant is the part of the quadratic formula that's underneath the square root symbol. Actually, let's just break that down first. The quadratic formula tells us some x value. It's always finding a solution to a quadratic. It's telling us what x value would make that function equal to 0. And we find that by using negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And that seems like a complicated formula, but really it's just coming from the standard form, of a quadratic, where the number in front of the x squared is a, the number in front of the x is b, and the number at the end, the constant, is c. Those numbers just get plugged into that formula. So it's really just following order of operations. You're not plugging in any x values in there. You're not plugging in this x squared or the x. You're actually just taking the coefficients a, b, and then the constant c and plugging them into that equation. One part of this, called the discriminant, tells us a lot of information. The number underneath that square root tells us how many real, irrational, or rational solutions we have. Okay, so that number, actually let's just imagine what that really is talking about. The square root of some number. When we get a nice perfect square under that number, let's say we had 16 underneath the square root. The rest of this top part, at least, is negative b plus and minus the square root of that number, which would be 4. Which you can imagine, that's going to turn out pretty nicely. That's going to actually just give us a nice rational solution. Actually, it's going to give us 2 rational solutions because we're adding and subtracting. We'll see that part later. But really, the number under the square root tells us whether we're going to get a rational number based on whether this is a perfect square. Since 16 is a perfect square, that gives us a nice whole number there, which we're then going to add and subtract from negative b, but really that turns out that the entire final answer is a rational number. If the number underneath the square root is not a perfect square, let's say it was 17, then this would give us negative b plus or minus, that's like 4.123, going on forever and not repeating the same pattern over and over, which makes that an irrational number. Okay, in general, the top example, when we have a perfect square, those generally should be factorable. The ones on the bottom are not factorable. This is an irrational solution, or 2 irrational solutions, but they're still real. Okay? Then there's 2 other types of examples. When we have the square root of 0, that actually just gives us 1 solution, because if you can imagine this, negative b plus and minus 0 would give us the exact same thing. Let's say I had negative 10, I add 0 to it, and I subtract 0 from it. It doesn't really matter. Either way, that's going to stay as negative 10. That would give us 1 solution. The final one is if I have a negative number underneath that square root symbol. So let's say I had negative 16. We don't know really how to deal with that right now. In Algebra 2, you'll learn a little bit more about imaginary numbers and how we call them I, or really it's a scalar of I, where you'd have negative b plus or minus, that's really just 4, but this negative sign makes that impossible to do. We can't multiply 2 numbers that are the same and get a negative number. So we would say that's plus 4i. That would give us 2 imaginary solutions. So these are really the 4 scenarios. This case should be factorable, where we get 2 rational solutions. This case is prime, but still has real solutions. They're irrational, but they're real. This is going to have 1 real solution, actually 1 rational solution. And this is going to have 2 imaginary solutions. So that's really what we're breaking down here. I'm going to break that down in a little bit simpler way. in these notes. And that's what this is really showing. The discriminant is just showing how many solutions and what type of solutions we have. If b squared minus 4ac, if that is a positive number, if it's greater than 0, we're going to have 2 x-intercepts. They might be rational or irrational, but if it's a positive number, I know I'm going to have 2 real solutions. And that's what I'm going to show on this example. I have negative, what is that number? I have b squared minus 4ac. My b here is negative 6. My a is 1. And c is 7. So I'm going to take those and plug them into that expression. Negative 6 plugged in for b. 1 plugged in for a. And 7 plugged in for c. Make sure you put those numbers in parentheses, especially if b is negative. That's going to be squared as a negative number. So it's negative times negative, that's a positive 36. Minus negative 4 times 1 times 7 is negative 28. And so my discriminant is 8. That's positive. It's not a perfect square, so these are going to be irrational, which I can actually tell from my original equation. This is prime. I cannot factor that. That's really why I'm getting a discriminant that's not a perfect square. That 8 is not a perfect square. It's going to give us 2 irrational solutions, which is really what prime means. It could mean that it's 2 irrational solutions, or actually it could end up meaning that we have imaginary solutions. But either way, that discriminant is positive. So I have 2 solutions. The second example is when that number equals 0. It's not positive or negative, it's actually 0. And that means that we're going to have 1 x-intercept. The function's going to bounce off the x-intercept and then go up in the other direction. It could also go down. It could be an upside down parabola, but either way, it's going to bounce off the x-axis and only hit the x-axis the one time. There is 1 real solution. So I'm going to do the exact same thing I just did. A equals 1, B is negative 6, C is 9. And I'm going to plug into b squared minus 4ac. So negative 6 squared again, minus 4 times 1 times 9. That's 36 minus 36. So my discriminant is 0, which means I have 1 solution. On that last example, when that discriminant is less than 0, it's a negative number, I have no real x-intercepts, which actually implies that I'm going to have imaginary x-intercepts. We're not going to really deal with those right now, but later you will see that you can actually find these imaginary solutions. So I'm going to do the exact same thing again. A equals 1, B is negative 6, and C is 11. So I have negative 6 squared minus 4ac, or 4 times 1 times c, which is 11. So that gives me 36 minus 44, or negative 8. So I have no real solution on that one. Because in the quadratic formula, all I'm really trying to do is take the square root of this discriminant. And I can't, right now at least, take the square root of a negative number. I'm going to do a few more examples with you. The Again, I'm just doing the discriminant part. I'm not actually finding solutions. I'm finding how many solutions I have. That's the question the discriminant really answers. It tells me how many solutions I have. And the answers for that question, for right now, are going to be 0, 1, or 2. So I'm looking at my A, B, and C from this equation: 1, -2, and 3. A is 1, B is -2, C is 3. So B squared minus 4AC. -2 squared is 4. Minus 4 times 1 times 3 is 12. That gives me -8. That has no real solutions. If the discriminant is a negative number, I don't have any solutions. I don't have, in the real number system at least, I don't have any time that that function's actually hitting the x-axis. Number 2, my A is 9, my B is 12, and my C is 4. There's going to be times when you might need to rearrange this equation into standard form, so it should look like this, where the x squared is first, the x is second, and then the constant comes third, and it's equal to 0. That's really important, that this equation equals 0. So I have b squared, or 12 squared, minus 4ac. 12 squared is 144. 4 times 9 times 4 is also 144. So I'm doing 144 minus 144. That gives me 0. The discriminant equals 0. That does not mean I have 0 solutions. Actually, it means I have 1 solution. All right, on number 3, A equals 1, B equals 3, C equals 11. So 3 squared plus, oh sorry, not plus, minus 4ac, or minus 4 times 1 times 11. That's going to give me 9 minus 44. And that's going to be a negative number. I actually don't even really care about what negative number that is, but it's negative 35. That means I have no real solutions. And on number 4, that looks a little bit different from standard form, but it's only because I'm missing my c. If you want to, you can rewrite this as x squared plus 2x plus 0 equals 0. So if you don't have one of those numbers, I would actually replace that term with a 0. So if you're missing a b, I would replace that b with 0, just so you can see clearly what you're using for a, b, and c. Here I know that c equals 0. My b is 2, and my a is 1. So I'm going to do b squared, sorry, actually let's take that one step at a time. 2 squared minus 4ac, so that's going to give me 4 minus 0. 4 times 1 times 0 is just 0. And that gives me 4. So the discriminant is 4. It's a positive number. That means I am going to have 2 real and actually rational solutions.